All right, we just focused on helping students understand the traditional algorithm with regrouping. I want to comment here right now. So that may have seemed quite procedural, what we were doing there, especially as we were saying, do this, do this, do this. But that conceptual knowledge, that thinking about, well, what does it mean to add, that is embedded within the traditional algorithm. And it's for this reason that I will always talk about that you're never just learning procedurally and you're never just learning conceptually, but you're always learning about procedures and concepts in tandem. And that's going to be particularly the case as we get to this next category of addition computation, which is using the traditional algorithm with regrouping. So what does it mean to regroup? Regrouping is regrouping 10 ones for 110 or 10 tens for 100. You might also call this trading or exchanging. I will likely use the term regrouping quite a bit here, but you use the terminology that makes the most sense for you and your students. So we are going to think about how we would help students understand how to use the traditional algorithm with regrouping for a problem such as this. Now we are going to use base 10 blocks here. I'm going to use a virtual version of those, so I'm going to scoot off camera so you can see what that looks like. And then I'll come back and we will use a hands-on tool, the place value disks, to solve this same problem. So let's get started. 26 plus 15. First, I want to draw vertical lines to separate the place values, and then I would show each of those add-ins with the base 10 blocks. I showed 26 with 2 10s and 6 1s, and then I showed 15 with 1 10 and 5 1s. Now, as we think about using the traditional algorithm, the first thing we're going to do is add the ones, where it's going to be helpful to think about this starting with the greater add-in. So I'm going to add 6 plus 5. Now here, I could talk about 6 plus 5 as putting two parts together, or I could talk about 6 plus 5 as having a set of 6 and joining 5 to that set. That's where that conceptual knowledge comes into play. After we think about that interpretation, I'm going to combine 6 plus 5. Now, I have to ask myself, do I have more than 9 ones? If I do, it's time to regroup. And here I'm going to regroup 10 ones for 1 10. So I'm going to remove those 10 ones and exchange them for 1 10. And notice how I place that 10 in the tens place. 10s go in the tens place, 1s go in the ones place. We are not going to put them anywhere else. So then it's time to add the tens. Here I'll start with the greater add-in, so I'll add 2 plus 1 plus that other one. And then I should ask myself, do I have more than 9 tens? Here we only have 1, 2, 3, 4 tens. That's not more than 9, so I don't have to regroup the tens. So I don't have to do anything else. Maybe if for a subsequent problem, I would have to add in the hundreds column. But right now, I'm going to write the sum. 26 plus 15 equals 41. Now, as promised, I said we are going to do the same problem, but now let's use a hands-on tool. So we are going to think about how we could help explain 26 plus 15, and now let's use those place value disks. So let's use our place value disks. Here I have 1s, 10s, and 100s to show what it means to add 26 plus 15. First, I show this first add-in with the place value disks. That's 2 10s and 6 1s, 1, 2, 3, 4, 5, 6. And then I'm going to show 15 with 1 10 and 5 1s, 1, 2, 3, 4, 5. Now with the traditional algorithm, one of the things I should have done is drawn a vertical line there to separate the place values. That might be helpful for me to focus on the different place values here. But now with the traditional algorithm, I'm going to start adding in the ones place. That means I'm going to add all of the ones together. So I'm going to put all of the ones together just like this. And then I want to ask myself, do I have more than 9 ones? And if the answer to that is yes, I have to regroup. So let's see, I have 1, 2, 3, 4, 5, 6. I'll put them in a group here. 7, 8, 9, 10. Oh my gosh, I do have more than 9 ones. Whenever I have 10 ones, I'm going to take those 10 ones and I'm going to regroup them or exchange them for 110. So I'm going to remove these from my mat, and I'm going to bring in that 110. And what does that look like when I do that with my paper and pencil? I'm going to write that 1, that regrouped 110 there in the tens place. And then I'm going to add the tens. I'm going to bring them together. I ask myself, do I have more than 9 tens? I have 1, 2, 3, 4. I don't have more than 9. So I could go ahead and write my sum. I have 1, 1, and I have 4 tens. So when I add 26 plus 15, my sum is 41. Now let's not use hands-on tools or virtual tools. Let's use our paper and pencil to solve this problem, 153 plus 79. What's the first thing we should do? Well, I'm going to draw vertical lines to separate my place values. So here I have a ones place and a tens place. I'm going to go ahead and separate those. And here I have a tens place and a 100s place. So I'll go ahead and separate those. So now let's think about how to support students as I solve a problem without those virtual tools or those hands-on tools. And let's think about solving 153 plus 79 with our paper and pencil. So what's the first thing we should do? First, let's draw those vertical lines to separate the place values. Here I have a ones place and a tens place. I'm going to go ahead and draw a vertical line down there to separate those place values. And I see a tens place and a hundreds place. Let's go ahead and draw a vertical line there to separate those place values too. The first thing that I'm going to think about after doing the vertical lines is adding the ones place. That's going to be really important with that traditional algorithm. Here I have 3 plus 9. 3 plus 9 is 12, so I'm going to go ahead and write, well, let's talk about it first before I do any writing. I have 12 ones. If I have more than 9 ones, I have to regroup. So 12 ones is 2 ones, and then I have this regrouped 10. I always like to point out that I still wrote 12. I just wrote it in a different way by writing the 1 of 12. That's 1 10 and 2 ones. And so I wrote the 10 in the tens place and the ones in the ones place. Then I'm going to go ahead and add the tens. Here I have 5 plus 7. 5 plus 7 is 12. Plus that regrouped 1 is 13. So here I'm going to write the 3 in the tens place, and then I regroup that 1 to the hundreds place. And then I have to add the hundreds. Here I have 1 plus 1. 1 plus 1 is 2. So what is our sum here when we add 153 plus 79? The sum is 232. So now it's time to push pause. I would like you to think about the hands-on tools or the virtual tools that you might use to help students think about addition without regrouping, and how those might differ or be the same from some of the tools that you might use to help students understand the traditional algorithm with regrouping. Go ahead and think about whether you might use different tools based on whether you're regrouping or not, and explain your thinking.